All right, let's just jump right into one of the biggest, most mind-bending questions in all of science. Why is the universe not just expanding, but why is it expanding faster and faster every single second? Seriously, it's a mystery that has pretty much turned our whole understanding of everything on its head.
You know, if you've ever tried to get your head around this whole thing, it can feel, well, kind of backward, right? It almost sounds like scientists found a result that completely broke all their theories, and instead of, fixing the theories, they just invented some mysterious dark stuff to plug up the holes. But what if that's not what's happening at all? What if this confusion, this apparent contradiction, is actually the very first clue in a massive cosmic detective story? A case where all this conflicting evidence doesn't mean the investigation is busted. No, it means the mystery is way deeper, and the truth is way more interesting than anyone ever dreamed of.
So, first things first, let's set the scene of the crime. What did we think we knew about how the universe worked?
For most of the 20th century, the story seemed pretty simple. You have the Big Bang, everything flies outwards, and then you have gravity, the force that pulls everything back together. We thought of it as a kind of cosmic brake pedal. The only real question was gravity strong enough to eventually stop the expansion and yank everything back in a big crunch, or would the universe just expand forever, but slower and slower over time? But then, when astronomers finally built telescopes powerful enough to actually go out and check, they found something that should have been totally impossible. The brakes weren't on. In fact, it looked like something had its foot slammed down on a cosmic accelerator. The expansion of the universe was actually speeding up. Now look, an extraordinary claim like that needs some pretty extraordinary evidence. And in the late 1990s, astronomers found their smoking gun. So, this idea of a force pushing the universe apart wasn't totally brand new. Einstein himself had played around with the idea way back when, but he famously called it his greatest blunder after Hubble proved the universe was expanding. It was basically a dead issue. But then, in 1998, two completely separate teams of scientists brought the idea roaring back to life, all thanks to using exploding stars as cosmic mile markers. The clue that changed literally everything came from these incredibly distant exploding stars called supernova. You can think of them as standard light bulbs out in the cosmos. We know how bright they're supposed to be. And based on every theory we had, they should have appeared brighter, meaning they should have been closer to us. But the bombshell discovery was that they were dimmer, way dimmer. And that could only mean one thing. They were much, much farther away than predicted. The only way that's possible is if the universe's expansion has been speeding up over time. This was the proof. And just like that, this one discovery totally rewrote the recipe for the entire cosmos. It turns out that everything we see, all the stars, the planets, you, me, everything, makes up only about 4% of the universe. The rest is a mix of mysterious dark matter and this even more mysterious dark energy that's pushing everything apart. Let me just say that again. 96% of our universe is made of stuff we can't see and have absolutely no idea what it is. Okay, so we have our culprit. We're calling it dark energy. But what on earth is it? Let's take a look at the lineup of prime suspects. So at its simplest, dark energy is just the name we've given to whatever is causing this cosmic acceleration. It acts like a repulsive force, a kind of anti-gravity. But it only seems to work over these huge, vast cosmic distances, pushing galaxies away from each other and overpowering gravity's pull. Right now, the whole investigation basically splits down two main paths. Is dark energy some kind of new thing in the universe, a new energy field that's just woven into the fabric of space itself? Or is it a sign that we've got the rules wrong, that maybe Einstein's theory of general relativity, as amazing as it is just incomplete? New stuff or new rules? Well, the leading candidate for new stuff is something called vacuum energy, the idea that empty space itself has an inherent energy. It's the simplest explanation. The problem? When physicists try to calculate how strong this energy should be using our best theories, the number they get is, well, it's just spectacularly wrong. I'm talking off by 120 orders of magnitude. That's a 1 followed by 120 zeros. It's the most wrong prediction in the history of physics, which basically screams at us that we are missing something huge. This mystery is so big, so profound, that we have built some of the most advanced, most incredible scientific instruments in human history just to try and crack the case. It's time to bring in the big guns. Our high-tech detectives are on the case, and they're designed to hunt for new clues out there in the dark.
We've got two star detectives leading this investigation. On one side, you have the European Space Agency's Euclid telescope. Its job is to create this enormous 3D map of the universe, looking back in time to see how dark energy's influence might have changed over the last 10 billion years. On the other side, you have NASA's James Webb Space Telescope. It's looking at the universe closer to home, measuring the current expansion rate with more precision than we've ever had before. So one is mapping the history, and the other is nailing down the present.
Now, you would think with tools this powerful, the picture would start getting clearer, right? But in a pretty stunning plot twist, the latest clue has only made the mystery even deeper.
At the heart of this brand new twist is one single number, the Hubble constant. It's simply the number that tells us the universe's current expansion rate. And everything, I mean everything, depends on getting this one number right.
Okay, so based on everything we know about the early universe, just after the Big Bang, our best theories predict that the expansion rate today should be about 67 kilometers per second per megaparsec. Don't worry about the units, it's just a giant cosmic distance. The important part is the number, 67. That's what the past tells us the present should be. But when our best telescopes, like Hubble and now Webb, with its incredible precision, actually go and measure the expansion rate today, they don't get 67, they get 73. Now that might not sound like a huge difference, but in cosmology, it's a canyon. And thanks to Webb, we now know for sure this isn't some measurement error. It's a real fundamental conflict between what the early universe predicts and what the universe is actually doing today. They call it the Hubble tension, and it tells us our cosmic story is still missing a key chapter. So how do we solve this? Well, physicists are throwing some truly wild ideas out there. What if there was a short burst of early dark energy that gave the universe an extra kick right after the Big Bang? Or maybe they're exotic new particles that we've never detected. The bottom line is, the Hubble tension might be forcing us to add even more strange new ingredients to our cosmic recipe. And this is exactly how the scientists on the front lines see it. Adam Rice, who is one of the original Nobel Prize-winning discoverers of this whole thing, doesn't see this tension as a failure. He sees it as an incredible opportunity. The universe is practically screaming at us that our story is incomplete. And that leaves us with one final, really fascinating thought. For 100 years, we thought we knew the main characters in our cosmic drama, matter and gravity. But maybe, just maybe, the real protagonist of this story hasn't even walked on stage yet, and we're all just now realizing we've been watching a play without having a clue who it's truly about.